All right, so the population of Adamsville grew from 10,000 to 17,000 in 7 years. Um, and assuming uninhibited exponential growth, we want to figure out what's the population going to be after 5 more years. All right, well, so the law of uninhibited exponential growth is P equals P sub 0 e to the kt. In order to utilize this equation, in order to figure out future populations, I need to know two numbers, P sub 0 and K. Typically, we're told what P sub 0 is. P sub 0 is the population at time 0. You know, it's the initial population, and the initial population we're told is 10,000. So let's go ahead and plug 10,000 into the equation. At this time, the next task is to figure out the value of K. Once I find K, we can then use the equation to figure out any information we want. All right, so we're told that in 7 years the population will be 17,000. So we're told that if T equals 7, then the population, the P, will be 17,000. So I can plug these two numbers in. Right, so P is going to be, I'm going to turn that into a 17,000 equals 10,000, and we're going to plug a 7 in for the T. And now we're going to use algebra to solve for K. Okay, so when we're solving an equation that has an E in it, we're going to end up having to natural log both sides to get rid of that E. But we can't, we don't want to natural log both sides until the coefficient of the E is 1. It's currently 10,000. So I need to first divide both sides by 10,000. Again, the reason why we're dividing by 10,000 is to force the coefficient, to force the number in front of E to be a 1. And now that that's done, we can natural log both sides. And I'm going to go ahead and reduce the 17,000 over 10,000, and we natural log the right side. And the natural log function and the exponential function with base E are inverse functions. So when we compose them, they cancel out. And so we're just left with 7k. That's why we natural log both sides, to get rid of the E. And then to solve for k, we would now divide both sides by 7. But to avoid the complex fraction, instead of dividing by 7, we could look at it as multiplying both sides by 1/7. And so if I multiply both sides by 1/7, I would have 1/7 natural log 17/10. And if I multiply the right side by 1/7, it would cancel out the 7. And so now I have k. All right, so k is equal to 1/7 natural log 17/10. So that's kind of a weird number. But now we're going to take that value and plug it back into the equation. Okay, so if I do that, it looks like I'll have P equals 10,000 e to the k, which is 1/7 natural log 17/10 times t. Now I'm going to work on simplifying this. I'm going to multiply the 1/7 and the t together. Doing so gives me e to the t over 7 natural log 17/10. And at this point, I can take advantage of the power of logarithms property, which tells me that I can take this number and move it to the exponent spot on the logarithm. So P equals 10,000 e to the natural log 17/10 raised to the t over 7 power. And the reason why we did that is because now the e and the natural log cancel once again. And so we have P equals 10,000 times 17/10 to the t over 7 power. And now I have a simplified formula here that I can use to predict population in the future. We want to know when the population will be, what will the expected population be in an additional 5 years? So that's 5 years after the 7 years. an additional 5 years. So we want to know what the population will be in 12 years, 12 years after the 10,000. So we're going to plug 12 in for t. So we have p equals 10,000 times 17 over 10 raised to the 12 over 7 power. And this is the place where I now need to pick up my calculator and use the order of operation. I have to utilize the order of operations. So I need to figure out what 17/10 raised to the 12/7 power is first. So depending on what type of calculator you're using, the order in which you hit buttons might vary a little bit. I'm using a Texas Instruments calculator, and so I hit parentheses, and then 17 divided by 10, and then close the parentheses. And then I use my exponent button, the hat button, and then parentheses 12 over 7, and close the parentheses. On my calculator screen, this is what it looks like. I have 17 over 10, and then the exponent button or hat button, and then the 12 over 7. This is, for some people, just simply entering this in the computer can be potentially the hardest part of the problem. And so we have to type in 17/10 in parentheses, and then we raise that to the 12/7 power, and then hit enter or equals. And my calculator says 2.48 and a bunch more decimals. And so now I'm going to multiply that by 10,000 and hit enter or equals. And back up here, they tell me to round to the nearest whole number. And if I round my solution to the nearest whole number, I get 24834. I have 0.49275 after that in my calculator, but rounding to the nearest whole number, this would be the answer. So this is the expected population of Adamsville after an additional 5 years.